Let's discuss the most important Jenkins features. As we have already discussed in the introductory modules, basically, Jenkins is a continuous integration and continuous delivery platform. So at the core, Jenkins is only an engine which helps you build flexible and extensible DevOps pipelines. That means that all the shell commands, all the tools, frameworks, and the respective versions like Java, Maven, and other such dependencies used in Jenkins jobs are used from your Linux machine as the source. For instance, if you want to use Maven in one of your Jenkins jobs, but you don't have Maven installed in your CentOS system, Jenkins will not be able to execute the job because it does not come pre-bundled with the tools. Or for instance, as part of your job execution, if a particular script executes echo $Java_home as a shell command, Jenkins will execute the command exactly as if you executed the command on your terminal window. The only difference is that Jenkins will execute the command under Jenkins identity. So with that understanding about Jenkins, let's start our deep dive journey and create our first new job. During this walkthrough, you will get familiar with various aspects of Jenkins' job. Let's name our job Test and select Freestyle Project as project type. Okay, let's begin from the very top of this page. Here is our project name. The description is just a descriptive text which explains what is the purpose of this job. This description value can be optional. Let's move on to other options. Please note that Jenkins provides us a lot of helpful tips. You can click here on the help icon right beside that field, and a very helpful descriptive tooltip is made available to you. This is quite handy, of course. Anyway, as you can see, there are tons of options available for Jenkins jobs, and we will guide you through the most necessary ones. First and foremost, let's make sure that we set this project to be a parameterized project by selecting this option. What does this mean? It means that you can add any parameters to your job. These parameters can be used as placeholders in your job definition, or steps and the actual values of the parameters can be passed in at runtime. It can be a special password, a special string parameter, file parameter, or some other options. These parameters make the job very flexible and portable. Let's move to the source code management section. In most build pipelines, this is one of the most important and basic steps we need to configure. Basically, your continuous integration and continuous delivery process start with these options. Because in most cases, the DevOps pipelines need to pull current source code for compiling and building the source and producing the build artifacts. Your source code could live in repositories like Git or Subversion or any other tool you use to manage your source code. Say we are using Git. Here we can select the option and input the repository URL for our Git repo. You can also specify your credentials and the particular branch of our source code repo we want to monitor. Let's move on to build triggers. Build after other projects are built. This particular option is really important, especially for our pipeline setup and configuration. Other options are build periodically, build when a change is pushed to GitHub, and poll SCM. Build periodically is based on cron expressions and will trigger builds based on the cron expression we define. If you're not familiar with cron expressions, you can click on the help icon and read all about it. Jenkins provides a pretty good tutorial right here. If we take a quick example and build a very simple cron expression with 5 asterisks, that means that we now have configured this job to build every 1 minute. Here, the first asterisk is for minutes, the second one for hours, next one is for the day of the month and for the weeks consecutively. The next option is to build when a change is pushed to GitHub. When we select this option, Jenkins monitors the Git repository and triggers a build when a code change is pushed to Git by a software engineer. This is a pretty good option to build your code actively and ensure no integration errors occur as developers introduce new code into the project. But it does have a drawback. Say if you have a very efficient software engineering team who is pushing code very frequently, then each commit will trigger a new build one after the other. That means that your Jenkins job will be quite busy building and rebuilding after each code push from your superstar team. That is why the last option of poll SCM is the most suitable option in most cases. It has all the benefits of build periodically and build when change is pushed to GitHub. With this option, you just need to manage what time and how often Jenkins will check the source code management system for changes. The source code management system could be Git or Subversion or any other system. Here in this example, we are specifying that Jenkins should check our source repo every 5 minutes for changes. If it detects some changes in the repo, Jenkins will trigger a build. But if there are no code changes detected, then Jenkins' job will just go back to sleep and wait for the next check to occur. In most real-world projects, we use poll SCM function. It is arguably the most logical option we can use in a multi-user environment. Let's move on to build environment. Here you will need to understand this particular option called delete workspace before build starts. Why is this important? Because as Jenkins starts to build and rebuild your source code for a build job, it may generate tons of temporary files which are stored in the workspace for a particular job. Since you can store multiple builds to preserve a historical track of your builds, you may end up with a lot of these files on your build server. Say if this particular project produces 1 gig of files and artifacts, and you decide to keep the last 10 builds on your server, then this project alone will require 10 gigs or more of disk space on your server. Moreover, these temporary files may also interfere with the new builds being run. That is why it is highly recommended that you select this option to delete workspace before build starts. It will keep the server disk usage in check and make the build process more robust and efficient. Now let's move on to the build section. Here you can define the specific steps that you want to add to your build job. For instance, if we select this menu, Add Build Step, we will be presented with some options like Execute Windows Batch Command, Execute Shell, Invoke Ant, Invoke Gradle, Invoke Maven. These are the default steps which are pre-installed by Jenkins and the default plugins we installed. As we install more plugins in our Jenkins instance, correspondingly more options will show up here. Out of these default options, the most useful one here is Execute Shell. This build step will execute shell commands on your Linux machine or on any other machine where your Jenkins instance is installed. There are these other options available to us as well, like Invoke Ant, Invoke Gradle, and Invoke Maven Target. These commands are built for tooling. For instance, we can use Maven package here to execute a Maven-specific step. But we can achieve the same effect by specifying mvm package with a shell command, and it will be almost the same as invoking top-level Maven package here. So it really comes down to our choice. Most of these tooling-specific steps could be accomplished just as easily via shell command steps. In some cases, though, it will be more convenient to pick a tool-specific step so that we can get the inbuilt configuration and validation user interface for that step with Jenkins user interface. The other main difference between these options is that this shell command will use the default settings on your Maven installation on your Linux instance, whereas a tool-specific step can be parameterized and can provide you more control. With the Maven-specific step, here you can set your Maven configuration by specifying a settings file, global settings, or even choose a specific JVM version of your Maven step. So this Maven step provides a lot more granular control. Let's move to the post-build actions. These post-build actions are also important for us. First of all, you need to know because of these post-build actions, you can create your pipelines by using the Build Other Projects option. In the previous versions of Jenkins, you were able to achieve this effect with the use of some special scripts. But now you can just select this option, Build Other Projects, and Jenkins will create and maintain dependencies between different Jenkins jobs. Also, you can archive the artifacts here, or even create a special email notification. email notification will send you an email through an SMTP server as part of the job execution. Basically, it will notify you and your team about the status of a build job via an email. This will keep the team well informed about the build status and will help them resolve any issues readily. Here are some other important options available, like Git Publisher or Delete Workspace when build is done. These could be very useful in many situations. Another important point to note here is that in your Jenkins job definition, you can use the environment variables, which are available on your Linux server. For instance, here we are using Java home variable in the shell command step for your Jenkins jobs. There are other environment variables which are also generated by Jenkins. You can also use these variables in your jobs, like for example, build number. We can use this variable in a similar manner to our environment variable. We just need to use the $sign in front of the variable name. Echo $build number. At runtime, this value will be generated by Jenkins, and this variable will be replaced with the real value as the build is running. And we are free to use this variable value any way we see fit within our build job. For instance, we can use it in the name of our artifact output file name to distinguish artifacts originating from different builds. Okay, that is our first job, which is a very simple job. Let's save it. And now we can see it has been configured within our Jenkins server. To start this job, all we need to do is run it by clicking on this run icon. By the way, we can't see any progress right now. For that, we will need to refresh our page. In Jenkins, there is a handy option available on the top right corner which can enable auto refresh of our page. If it is not enabled, Jenkins will not automatically refresh this page and we won't see our progress unless we refresh the page manually. Only after refreshing will you see progress which confirms that our job has succeeded. Let's switch auto refresh on. And now let's rerun the job. This time around, Jenkins will automatically refresh the page and let us know about our job status, success, or failure. Now as you can see, the job ran for 0.1 seconds and there was no failure. Excellent! So we just configured and ran our first Jenkins job successfully. Now let's talk about Jenkins Pipeline. Jenkins Pipeline is a suite of plugins which support implementing and integrating continuous delivery pipelines into Jenkins. Pipeline provides an extensive set of tools for modeling simple to complex delivery pipelines. Before we get started with Jenkins pipelines, we first need to install the required Jenkins plugins. Let's do that now. The basic pipeline add-on is already installed in Jenkins, but we need a build pipeline plugin. Let's click on Manage link on the menu located on the left-hand side, which takes us to the configuration section of Jenkins. Here we click on Manage Plugins. Go to Available tab to list the available plugins. These are the plugins available in the Jenkins plugin ecosystem and have not yet been installed on this Jenkins instance. Here use the filter to search for build pipeline. And here it is. Let's install this plugin without restart. Now our Jenkins build pipeline plugin has been installed. Now that our pipeline plugins are installed and ready to go, we can create our first build pipeline view. To create our pipeline view, click plus icon right here and specify a name for our pipeline. For example, let's use tetra_noodle_pipeline_test and check build pipeline view. Click OK here. Now here we are in the detailed configuration section of our pipeline. This first field is the name of our first pipeline view. Here is the description, which is always optional. Here are some necessary options. First is title. Your pipeline view can have a title which is separate from the name of this pipeline job. Let's specify Title 1 for the pipeline title. Next, the most important option you don't want to miss is the initial job. This setting specifies the job that will start your pipeline. We will choose our test job because that is our only one available in our Jenkins instance for now. Let's go over other options. It is recommended that you check these options. Show pipeline project headers. Show pipeline parameters in project headers. Show pipeline parameters in revision box. All of these options will help you get more information about your pipeline build. All other options are really optional, and we will accept default values for them. Let's click Apply to set up our build pipeline view. Here it is, our first build pipeline with its own title. This view represents the steps involved in this pipeline in a visual manner. Besides being able to visualize our whole pipeline, we can also view the console output for our job steps. We just need to click on this little icon on the lower right corner and we get a detailed output for this job step in our pipeline. A quick little note about this user interface. If you have enabled auto refresh here, when you are viewing your console output, due to the auto refresh, Jenkins can automatically close this console pop-up. That is why if you don't want to have your console output closed automatically all the time, just disable auto refresh. Anyway, we will create a more realistic pipeline in the future, but for now, let's review how it works. Here, we already have one test job. Let's create another Jenkins project and name it Test 1. For the project type, we will pick Freestyle Project again. We won't make any specific changes in the settings here, but just execute a shell command to print out the build number. These are simplistic jobs which do not accomplish much. We just need these jobs to go over the basic pipeline concepts. We will create much more useful Jenkins jobs in the upcoming videos. The idea here is to show you that in order to build our pipeline, we need to chain our jobs to be executed one after the other. And the way to do this is by editing our first job, and we need to configure it with the PostBuild action. Let's go to the Jenkins homepage, and here click on our test build job, which is our first job in the pipeline. Now let's click on the Configure menu on the left-hand side. Scroll down to the bottom of the page and configure one PostBuild action. The PostBuild action we will select here will be of type Build Other Projects. And for Projects to Build field, we will pick the second job in our Jenkins instance we just created called Test 1. So basically, what we are saying here is that when test project is completed and is stable, then build our Test 1 project. So you see how this is taking the shape of a chain of projects, or a pipeline. Let's save this job and go for our tetra_noodle_pipeline_test view. Here we can see when our first job will trigger, and after it is successfully done building, our next job will be triggered automatically. Let's try it out. Don't forget that we need to refresh the page manually to review progress since we have disabled auto refresh. Here it is. Now we can see that after our test job was successfully built and once completed, it automatically triggered the build for the second test job and both jobs have turned green to signify that both have succeeded. So why exactly do we need the pipeline and build pipeline add-on? Well, in real-world projects, where we have tens or hundreds of components to build, we need to ensure that all the components are working properly even as changes occur in only a few components. For instance, the middle layer components may depend on data access components, and web components may depend on middle layer components. Granted, similar chaining can be achieved via PostBuild actions, but it is quite difficult to visualize multiple build chains just using these PostBuild actions. Build Pipeline plugin provides a much friendlier graphical interface, which helps us visualize the whole pipeline at a glance. For example, here is an example of a real-world pipeline. This particular pipeline starts with this git source job, which pulls the source from our Git repo. This Git job can stage the source and then trigger two separate jobs, analysis and sonar analysis. Sonar is a very cool code analysis tool. This is an example of splitting a pipeline into parallel sub-pipelines. The analysis job itself can trigger another job called deploy for customer. And then analyze sonar job can trigger a job called deploy for developers. So this is a good example of a real-world build pipeline. This pipeline serves multiple purposes. It builds the source. It analyzes the source code using the sonar tool. Moreover, it also triggers 2 different deployments into different environments. All this is triggered off by a single source change. And when we wrap all these steps into a build pipeline, Jenkins helps us visualize everything in a very clean and intuitive way. Not only that, this also gets updated as the pipeline gets executed. So we can watch the progress of our pipeline in real time. Let's enable auto refresh and see what we've got here. Good. Our Git job triggered the other 2 analysis jobs. And there we go. It looks like all our jobs were successfully built at the end of this pipeline. We should have 2 successful code deployments, deployment for the customer and another deployment for developers. Anyway, we will look to build Pipeline plugin and its job more closely in upcoming videos.